Well, hello everyone. What we have today is chapter 6 essentially. The first topic within that is going to be an introduction to what are called rational expressions. So a rational expression is essentially a fraction. A rational is just another name for a fraction. So for instance, that is a rational expression. We sometimes use function notation. So you could just as equally, you could describe it using that. Now, if you want to find a value, let's say I'd like to know f of 6, and you just take 6, add 1, and 6, take away 3, top 2 add up to 7, bottom 2 get you 3, and we expect you to leave your answers in this format, so don't turn them into decimals and don't turn it into 2 1/3 or anything, just leave it 7/3, and we are pretty much call it good. Now, let's move on to most common type of thing you're going to be asked to do, and that is to simplify your rational expression. For instance, if I give you your rational expression, let's use a, b plus 1, and let's have this as a, b plus 3, you are allowed to simplify an expression like this, and the rule is any factor on the top, the numerator, can cancel out any factor on the bottom, the denominator, in a 1-to-1 basis. So that a will cancel out this a. And in this case, we're going to be left with a b plus 1, and over that is going to be b plus 3. And that is the simplified version of this. Do not try and do things that are not allowed. This b cannot cancel this b because this is not a factor. This is b plus 3 as a factor, not b on its own. And for that same reason, this b, or this b plus 1, cannot cancel with this b plus 3. This is plus 1, this is plus 3. They are not the same. If they are not the same, then you cannot cancel with a 1-to-1 ratio. So let's show you an example of simplifying a rational expression with one variable in it. So suppose we have 2a squared, take away 6a on the top, the numerator, and we have 18 take away 6a on the bottom. The strategy that you're going to use for all these situations is the first thing you're going to do, step 1, is factor all terms. So factor the numerator and the denominator. So let's see what we get here. 6 and 2, there's a common factor of 2. A and a squared, there's a common factor of a. 2 used up, one of the a's used up. A minus 2 into 6 leaves you 3. The a is used up. That is the total numerator factored. Now I have an 18 take away 6a. I can pull out 6 as a common factor, and that's going to leave me with 3 take away a. Now at first sight, you would probably think, well, there's nothing on the top exactly the same as the term on the bottom. Technically that is correct, but sometimes factors can be hidden. So step 2 will be to cancel common factor. Let me show you a little trick. Forget about these. There's going to be a little bit of cancelling, but let's forget about these. A minus 3 and 3 minus a are technically very similar. Show you what I mean. There's a 2, an a, and an a minus 3. And that's going to be 6. And this fella can be thought of as negative a minus 3. So if you have 2 terms subtracted, and on the bottom you have 2 terms also subtracted, but they're the difference, right? One's one way around and the other is the opposite way around. You can take out a negative and now you've got a common factor. So cancel common factor, cancel, cancel. That 6 will cancel with this guy and leave 3. And we are now finished. There's an A on the top. There's a 3 on the bottom. And it's negative. This is your answer. Let's try 5. Or at least a version of 5. So we have negative 5, a to the 5. Take away 10, a to the 4. Plus 20, a cubed. And on the bottom, we're going to have negative 5a cubed. Now, I cannot do anything really with the denominator, so I'll leave that alone. Now, there is a common factor between 5, 10, and 20, and that number is 5. There's an a cubed, an a to the power of 4, and an a to the power of 5. If all the terms contain a power of a, then the common factor is the smaller of the 3 choices. And then we'll see what's left. There's a negative here. The 5 is used up, and 2 of these are used up. So you've got an a squared. I should say 3 are left in the a squared. This one is negative. That guy's 2. And 3 of these are left used up, so you've got an a. And this guy is going to be plus 4. Now, as I look at this expression, I can now do some interesting cancelling. A cubed cancels with an a cubed. Negative 5 cancels with negative 5. That negative is there, but technically, if you cancel everything out, there's a 1 left behind. So you could write down the answer like that. Although we wouldn't consider that very good form. So all I'm basically going to do is use the negative 1 in all of them, which changes their sign. And there we are, we're finished. So let's look at doing as an example, quadratic. So this is going to be a version of 7. So I have x squared plus 3x, take away 18 on the numerator. And I have x squared plus 4x, take away 21 on the denominator. And so I only really have 2 main stages, factor and then cancel. So x squared, this is from our previous sections. You're looking for 2 numbers that multiply together, give you negative 18, and when you add them together, you get plus 3. So it's going to start with an x and an x. One of them has to be positive and negative, because you need one of each to get negative 18. And the combination that works is that one. Now you look at the bottom, and you're going to factor it. And we're looking for 2 numbers that multiply together to give me negative 21. So it tells me one has to be plus and one has to be minus. And the combination that works this time is 7 and 3. So I've now factored. I can then cancel 1 for 1. And we are left with an x plus 6 on the top. And then x plus 7 on the bottom. And remember, you are now finished. You cannot cancel this x with that, because these are not factors. That x is not a factor. It's part of x plus 6. X plus 6 is a factor. X plus 7 is a factor. They're not the same. They can't cancel. Suppose we add another level of difficulty. So I have 3x squared plus 12x, take away 15 on the top. And on the bottom, I have 15 take away 18x plus 3x squared on the bottom. Well, the first thing I would say is, look, you don't really like quadratics written in that format. So I'm going to begin by just rearranging the denominator. Okay. Now, let's go hunting for common factors. Before I start making life a misery, I'm looking at these guys and I'm saying, wait a minute, I can pull out 3 as a common factor. And I can also pull out 3 on the bottom as a common factor. And then I'm going to continue with the factoring. Top, x squared plus 4x minus 5. So I'm looking for 2 numbers that multiply together to give me -5. But when I add them, I get 4. Well, that's a plus 5 with a -1. On the bottom, I'm looking for 2 numbers that multiply together that give me +5. But when I add them, I get -6, which is that combination. I can now cancel this one with that one. And those also cancel. And I am left with that guy for that guy. And we're finished. Let's do a version of 9 now. 9 is a quadratic, but it has 2 variables in it, a and b, instead of your typical single variable, maybe x, for instance. So there's the first guy. The first thing I'm going to do is I'm going to look for simple common factors. So there's a 5, for instance, that we can do on the top. And there's a 5 that I can also take out as a common factor on the bottom. I then need to work on factoring each of these. So let me do the bottom one, the denominator. Hopefully you recognize that as what we call a difference of 2 squares. So if you ever say this guy take away that guy, that's the factoring. You can check it out by formula. Now we're going to look at how to do this fella. And the trick that we showed you last time is to make b equals 1 and write down what you get. Now we know how to factor this one. It happens to be a minus 1 times a minus 1, right? 2 numbers that multiply together give you +1, but when you add them, you get -2. And once we've done that, we then replace that with 1b, and we replace that with 1b. So we now know the factors of each expression. So the top one is an a minus b times another a minus b, and the bottom is an a plus b times an a minus b. And now we have those two cancel, and we're left with a much simpler fraction. So we've now simplified that, and it now becomes this guy. So you can see the main process here is factoring. If you can do the algebra of factoring, you are pretty much going to get everything that you need. So here is the last one. It's like the ultimate horrible. We are going to simplify this fraction on the numerator, and on the bottom we're going to have 200x plus 40x squared take away 16x cubed. Now, it's not that obvious what the factors are going to be when an expression gets really big and really ugly, as you can see here. But nonetheless, there is a kind of strategy. You start by looking for common factors. Well, there's an x, there's an x, and there's an x. That's definitely a common factor. You then look for some numbers, an 8, a 20, and a 100. And I try and find the biggest number that divides all of them, and I managed to get 4. Now, 2 left over, x squared left over, minus 4 into 25, one of these left over. 4 into that's 100, so you get 25, and that's the numerator. Now on the denominator, things are pretty messy. You've got a negative there, but we'll deal with that in a minute. I'm looking at numbers that divide all those. All I can find is 4 and x again. And you do this guy, you're going to get 50. You do 4, you're going to get 10 and an x. And you do this guy, you're going to get a negative, a 4 and an x squared, which is, just checking this. Oh, I just noticed something. Do you look at this guy? I pulled out 4. I could have done better. Sometimes you don't know it until after you've done it. I could have pulled out an extra 2 worth, so 8x, which makes that 25, which makes that 5, and that makes that 2x squared. So if I'd seen 8x, I would have went from here right to there. Now we have to deal with another quite horrible issue. Do you see this negative 2x squared thing that's going on here? We do not like quadratics with negatives. So what I'm going to do now is essentially a little algebra trick. I'm going to pull out a negative from here. And if I do that, this would be negative 25, this will become negative 5, and this will become plus 2x squared. So I'm going to put in a 2x squared, a negative 5x, and a negative 25. And do you see a rather nice result? This guy cancels out this guy. This guy cancels out this guy. This guy and this guy get you that. And so you're left with is 1 over negative 2, which is negative a half. So this entire expression ends up simplifying down just to negative a half. It's kind of cool and kind of amazing. Now, over the next couple of sections, you are going to have to deal with the process of factoring quadratics and other expressions and then cancelling to get simplification. So this is like the intro to that process. So hopefully in the next few days, you're going to get a lot more practice and therefore you'll get a little bit better at it as well, I hope. And that's all for now. Hope this was of use. Bye.